We're solving problem 12 from the 2020 F equals MA exam A. A point mass M is glued inside a massless hollow rod of length L in an unknown location. When the rod's pivoted at one end, the period of small oscillations is T. When the rod is pivoted at the other end, the period of small oscillations is 2T. How far is the mass from its center? Call the distance from the mass to its center x, where suppose this drawing shows that this dot's the mass. The d is the distance from the point mass to one of the edges, and then the other side is the total length, which is L, and then subtract d. So the period for angular frequency and small oscillations for a pendulum is omega is mgd over inertia. In this case, our inertia can be represented as I equals md squared. Therefore, plugging this value into our original angular frequency equation, we get that omega in this case will be square root g over d. By definition, we have that the period of small oscillations, which is t, is equal to 2 pi over omega, which you can say is proportional to the square root of the distance d. So now that we have all of these equations, we can start to formulate something. Now we can say that t over the square root of d is equal to the ratio of the period of 2t oscillations, this is the other side, over square root L minus d. Solving for this, you get that L is equal to 5d, or d is equal to L over 5. Now you want to solve for x. So this is like 1/2 of it, so x is L over 2, and then subtract this distance d to get this part. So since we found that d is L over 5, we plug that in. L over 2 minus L over 5 is our answer, 3L over 10. So this is our answer for this problem.